Welcome to the lecture series of signal system. In this lecture, we will start the second unit of the syllabus, which starts with the introduction of LTI system. But before this, there are some examples regarding how to test the stability and instability of a system. So there are few examples we will go through. After then, maybe in the next lecture we will discuss LTI system. The examples are here are some examples from the discrete time systems, where in some examples output is given, in some examples impulse response is directly given. I have to check whether the given system is stable or not. So first of all, I will let you know once again what is the condition for a system to be stable. It is bounded input and bounded output criteria to check whether a system is stable or unstable. Means if we are giving a bounded input to a system and it produces a bounded output in response to the bounded input, then the system is said to be a stable system, or otherwise it will be an unstable system. So if the impulse response of the system is given, we can apply the Bibo criteria, and there is a relation. If impulse response of the system is given, then impulse response of the system Hn, summation of impulse response where n is from minus infinite to plus infinite, modulus of Hn, remember this term, modulus of Hn should have a finite value. If we are adding Hn at different value of time from minus infinite to plus infinite, it should give a finite value. Then I will say that the system is stable, otherwise it is an unstable system. So look into the first example. Here it is given Hn is equal to 3 power n u of minus n. This is 3 power n u of minus n, because 3 power n is multiplied with u minus n. Then the nature of u minus n is it will exist for negative values of time only, for negative values of n only. Means n will take only negative values, means from minus infinite to 0. U of minus n will not exist, it will give a 0 value for the positive values of n. So because u of n only exists for the negative values of n, we will put only negative values of n to calculate the summation. Then the formula will become summation of 3 power n, where n is from minus infinite to 0 mod. This summation we have to calculate. So instead of putting minus infinite to 0, we will put 0 to minus infinite, and the power will become negative when we will change the limit. It is from 0 to minus infinite, then it will become 3 power, I can put it as mod of 3 power n. Then it will become 3 power 0 plus 3 power minus 1 plus 3 power minus 2 plus test 3 power minus infinite. or we can say that it will be 1 plus 1 by 3 plus 1 by 3 square plus 1 by 3 power infinite. This is a GP of the infinite terms, and to calculate the summation of this GP we have the formula A upon 1 minus R. Value of A means first term of the series, R means common ratio which is 1 by 3. Then this summation will give 1 by 1 minus 1 by 3, which is nothing but it is equal to 3 by 2. It means that this summation has a finite value which is equal to 3 by 2, and if impulse response of the system while taking the summation from minus infinite to 0 gives a finite value, this indicates that the given system is a stable system. It means that the system given in the example 1, it is a stable system. Next example is, it is cos of n pi by 2. Look at it here. The impulse response of the system is given directly. So what we have to do is we have to take the sum of this Hn, where n is from minus infinite to plus infinite. We have to take the summation of mod of Hn, and if it is finite then system is stable, otherwise system is unstable. So when we will take the summation, we will write it as cos of mod of cos n pi by 2, where n is from minus infinite to plus infinite. When we will put values of n from minus infinite to plus infinite, or we can say that it is a even function, then cos of minus theta will give the same value as cos of theta. So we can write it as 2 times summation from 0 to infinite cos of mod of cos n pi by 2. Mod of cos n pi by 2. So this summation can be written in this way also. The limit will change, instead of minus infinite to plus infinite, it will become 0 to infinite and 2 times of the function. So we can write it as summation 0 to infinite, n is from 0 to infinite, mod of cos n pi by 2. So here if n is equal to 0, the cos n pi by 2, for n is equal to 0, cos n pi by 2 will give value 1, because cos 0 is equal to 1. When n is equal to 1, it will become cos of pi by 2. It will become cos of pi by 2, and cos pi by 2 is equal to 0. When n is equal to 2, it will become cos of pi. Because we have to take only modulus, we does not have to take sign. Cos of pi will give value -1. Then instead of -1, I will write it as 1. When n is equal to 3, again it will V3 pi by 2, and value of 3 by pi by 2 means cos 270 degree will give value equal to 0. Again, when n is 4, it will become cos of 2 pi, and cos of 2 pi will give value 1. So from here we can observe that for the even values of n, 0, 2, 4, this will give value equal to 1, and for the odd values of n, means for n is equal to 1, n is equal to 3, it will give value 0. So when n will become even, it will give value 1. When n will become 0, when n will become even, it will give value 1, and when n become odd, it will give value 0. So we can write, it will become, the summation will give a value like, for odd values of n, it will give it will be equal to 1 plus 1 plus 1 plus 1 will be added infinite number of times. So the value of this summation will be infinite. Here in this case, the summation of impulse response from minus infinite to plus infinite is not giving a finite value, it is giving infinite. That means the given system is an example of an unstable system. Now move to the next example, which is written as, in the next example also, Hn means impulse response of the system is given. We have to do, we have to only take summation of this impulse response. So here we will put summation of Hn as, n is from minus infinite to plus infinite, n is from minus infinite to plus infinite, delta n plus cos of n pi, and it can be written as sigma minus infinite to plus infinite, delta n mod of delta n plus, here is mod, minus infinite to plus infinite, mod of cos of n pi. This summation will give value equal to 1. This summation will give value equal to 1 when n is 0, and for the other values of n, the value of delta n will be 0, and when n is 0, it will give value equal to 1. So value of this summation will be 1. But for the all values of n, either it is 0, either it is 1, either it is 2, it will give either minus 1 or plus 1. And because we are taking mod of this function, minus 1 will also become plus 1. So we have to add plus 1 from minus infinite to plus infinite, then this summation will give value equal to infinite. Because cos 0 is 1, cos pi is 1, cos 2 pi is 1, cos 3 pi, mod is there, it will make negative term positive. So we have to take 1 at infinite, we have to add 1 at infinite number of times, then it will become infinite, because summation of impulse response of the system gives infinite. 1 plus infinite is also infinite. It is giving infinite, means it does not have a finite value, it means that system is an example of an unstable system. Now here question number 4, which is e power 3n u of n minus 2. First look at this function u of n minus 2. It is shifted form of unit step function. So unit step function, because it is shifted by 2 unit right, it will start from n equal to 2. It is n equal to 1, it is n equal to 2. So this is unit step function un minus 2. This signal, this function is multiplied by e power 3n, then limit of e power 3n will also exist from 2 to infinite. So I will take summation of this function as n is from 2 to infinite 3 power 2n modulus. We have to take values of n from 2 to infinite. When I will put n equal to 2, it will become 3 power 4. When I will put n equal to 3, it will become 3 power 6. When I will take n equal to 4, it will become 3 power 8 plus 3 power infinite. So the total summation will not give any finite value, it will give infinite. It will give a value equal to infinite, because summation of impulse response of the system from minus infinite to plus infinite is not finite. It means that this system is also an unstable system, because it is not giving a finite value. The next example is as given here. Yn is equal to cos of xn. So in this example, impulse response is not given. It is simply given that input of the system is xn and output of the system is yn. So to get the impulse response of the system, we have to replace this xn by delta n. Then suppose xn is equal to delta n, then if xn is equal to delta n, then yn will be equal to impulse response of the system h of n. It means that h of n now is equal to cos of delta n. So we have to sum up this function cos of delta n for the values of n from minus infinite to plus infinite mod of cos of delta of n. So when we will put values of n from minus infinite to plus infinite, when we will put values of n from minus infinite to plus infinite, for all values of n, value of delta n will be 0. For all values of n, value of delta n will be 0. It will give value equal to 1 only at n is equal to 0. For the all other values of n, it is 0, and when delta n is 0, the cos 0 will become 1. So it will become 1 plus 1 plus 1 for the non-zero values of n, and when n is 0, it will become plus When n is 0, it will become cos 1. When n is 0, it will become cos 1, and again it will become plus 1 plus till the infinite. So the impulse response of the given system, when we will sum up this impulse response from minus infinite to plus infinite, it will not give a finite value. That means this system is also an example of an unstable system. Again I will repeat here, delta n will be equal to 0 for the all non-zero values of n. When n is equal to 0, it will give cos 1. For the other values of n, it will be 0 when n is not equal to 0. Then delta 1 will be 0 and value of cos 0 is always 1. So when we will sum up 1 from minus infinite to plus infinite, it will give equal to infinite. That's why the given system also is an example of an unstable system. Next and last from this slide is yn is equal to summation from minus infinite to n plus 5 x of k. Here also input is xk and output is yn. Then we have to replace xk by delta k. Then yn will become hn. So it will become h of n is equal to sigma delta k, where k is from minus infinite to n plus 5. It is minus infinite to n plus 5. We have to take summation of hn. N is from minus infinite to plus infinite mod of hn, and value of hn is, it will give value equal to 1 when k is 0, and we will put value of k from minus infinite to n plus 5, but for all the values of k, delta k will give 0, except when k equal to 0, it will give 1. So when I will sum up these values, it will become equal to 1. It means that we have to take summation of hn. It is from minus infinite to plus infinite. hn is 1, and we have to put n is equal to minus infinite to plus infinite. So we have to take summation of one infinite number of times, 1 plus 1 plus 1. It will go infinite number of times, and it will also give value equal to infinite. This system, impulse response of this system, when we summing up this impulse response from minus infinite to plus infinite, it will not give a finite value, and the system becomes unstable. So this is all about the stability of the system. In the previous lecture, we have seen some continuous time responses of continuous time systems, and we have taken them in account to test whether the signal is a stable whether the system is an stable system or it is unstable system. In this lecture, we have seen some more examples regarding discrete time systems. So this is all for stability of the system. Thank you.